Good morning. Are you looking for a requiz? It is on the little
No,
table
I'm
there.
not.
No, you're not. What are you here for?
I said that I would come during flex so that you could help me with.
Oh, but I'm not free on
acceptance.
Tuesday because I've got my tutorial right now. Whoa.
When
Can you come at lunch?
Lunch? Yes, sure.
Yes, perfect. I'll see you then. Okay, we are going to be on page 26. 26. You're welcome. It's on counting sig figs. Yeah, you feel ready for that? Okay, cool. Okay, so stoichiometry. I mean, there's nothing new here, right? It's just like regular stoichiometry. And if you recall, stoichiometry is all about finding the what quantity? Mole ratio and the moles. So you need a balanced equation, okay? And in this case, it's quite nice because you are given a balanced equation. And so step number one of any stoichiometry problem is always going to be find the what? Step one of any stoichiometry problem will be find the elephants. No, not elephants. Okay, if we're going to be using the mole ratio, what would we be finding? We would need to find the okay, in chemistry, when in doubt, find the meters. No, don't find the meters because that would be silly. Find the mountains. No? Well, molar mass, maybe. Find the mole. Find the moles. Find the moles. Step one, find the moles. Do you remember when we have stoichiometry, we have always got, whatever of our unknown, and then we will find our moles of our unknown. So that's step one, find the moles. Step two, find the moles, whatever of our known. I'm getting it backwards. Moles of our known. Use the mole ratio to get to your moles of your unknown. And then you would find your whatever you want to find of your unknown. I'll bet that if you did this problem, you probably could do it. You just weren't thinking about finding moles. I'll bet you would have found moles anyway. Okay. So, but we are going to be using the ideal gas law here. So either we're going to be using it in step one or in step three. So let's see what we've got. We have 4 moles of gasoline are burned. Gasoline is octane. So we have 4 moles of octane. We want to know the volume of O2. And we know that the pressure is 0.953 atmospheres. And we know that the temperature is 35.0 degrees Celsius. So what should we do with that number? Convert it to Kelvin. So we will add 273.15, which gives us 273.15 73.15 plus 35. I'm sure some of you guys could do that in your head, but I can't. 308.15 Kelvin. Okay. So step 1, 5 moles of the known. Oh gosh, we already know moles of the known, so we don't have to do anything there, right? So we are now looking for the volume of oxygen. So we're going to go from moles of gasoline, of octane, C8H18. We will convert that into moles of our unknown, which is our oxygen, because we don't know how much oxygen we have. Volume, moles of O2, and then we will convert that into the volume of O2. So moles of O2, starting with our 4 moles of C8H18, and we would cancel moles of C8H18, and we want to find moles of O2. Our numbers from the balanced equation are 2 octane or gasoline for every 25 O2. So 4 times 25 divided by 2 is 50 moles of O2. Now, it'd be really tempting to say, I have 50 moles of O2. Now I can multiply by 22.4 liters per mole and be done, except that we are not at STP. So what would we use instead? We would use the ideal gas law, the pervert equation, PV equals nRT, and we are looking for, in this case, V, so we're going to solve for V. V is equal to nRT over P. Do we need to do this, or are you guys okay with this? Do you want to do the calculation, or do you feel like we could plug them in and just chug through and we don't need to actually do it? Okay. Plug and chug. You should end up with how many sig figs? 3 sig figs. The answer to this example is in the answer key if you want it. How many liters of oxygen would be needed to produce 46 liters of carbon dioxide if the temperature and pressure of both are 0 degrees Celsius and 502 atmospheres? How many people feel like they probably could do that one? It's the same equation. We still have... Pardon me?
Was it the PV?
P1V1
Yeah.
over N1T1 is equal to P2V2 over N2T2. Yes, you could. You could do this. So the P, the T, the T's are the same. And the pressures are the same. So you know that V1 over N1 is equal to V2 over N2. And we know that we have, let's say that this one is, how many liters of oxygen? Oh, yeah, okay. So this would be CO2. CO2. Let's see if this actually works. It seems like it should. V1 would be O2. And this would be O2. Oh, actually, it's even better than, yeah, I'm just a dummy. Equal moles of gases at same temperature and pressure equal volume, equal moles of gases. Contain the same number of particles. So if we have 46 liters of CO2, it's going to end up being the same as this, to be honest. It's going to end up being the same. But you can use the mole ratio as a volume ratio because the volumes will be 2 to 20, it'll be 16 to 25. Yes, for every 2 liters of this, I would use 25 liters of this, and I would get 16 liters of this and 18 liters of that. Yes, because equal volumes contain equal number of moles when they are at the same temperature and pressure. Okay? You'll get the same result whether you do it this way. 46 liters of CO2 times, what was it, 16 liters of CO2 for 25 liters of O2. So we have 46 times 25 divided by 16 equals 71.875 liters of O2, and then we would round that to 3 sig figs, 71.9 liters of O2. But if we used this one here, we would have our volume of O2 is equal to our volume of CO2. So we got this and this over our moles of CO2, and then times our moles of O2. So what we've done is we've solved this equation for volume of O2. And you know what we're going to end up with? 46.0 liters times how many moles of O2? 25 moles of O2. And then, my moles of CO2 are 16, right? 16. Look what we have. We have 46 times 25 divided by 16. Is that what we had before? Yes. Could you use PV equals nRT to find your moles and then convert from moles of A to moles of B and then use PV equals nRT to convert out of moles? Yes, you could. Is that a pain in the ass? Yes, it is. So one of these two methods would work quite nicely. Okay? But you can brute force it the other way if you want to. All right, there's some exercises here. I will leave those for you to do. We are going to go on to 13.2D on page 29, and we are going to remind ourselves about limiting reactants. How many of you feel like you have any memory of what a limiting reactant is? 2, 3, 4. Okay, we most of it, yeah. Okay, we kind of know a little bit about it at least, right? So if you are given 2 reactants, quantities of 2 reactants, that means it is a limiting reactant problem. And that means you are going to be doing 2 calculations. Yes? Let's start, though, because it is a stoichiometry problem, by writing a balanced equation. Could you guys write a balanced equation for this reaction? Good morning.
Same thing.
Now, do you guys want to check your equation up here? We are told that we produce H2, and we're told that magnesium reacts with hydrochloric acid. So what type of reaction is this? Single replacement. So the magnesium kicks out the hydrogen. We get H2, and Mg is 2+. So it combines with Cl- to give us MgCl2. MgCl2 is aqueous. It is a soluble salt. All right, so 2 reactants, so we need to do 2 calculations. So we're going to find the moles of, eventually we want to find the volume of H2 gas. So what should we be finding the moles of?
H2.
H2. So we're going to find the moles of H2 produced from either one. So we have to say from Mg, and we need to find the moles of H2 produced from HCl. Can you guys do that, please? What do you do once you have those 2 numbers? You figure out which reactant is excess and which is limiting. Check my numbers. Did I get my answers correct? Or did I goof up somewhere? Because you know me, I make mistakes all over the place. Did I make a mistake? Give me a thumbs up or a thumbs down. Thumbs up, thumbs down. Thumbs up. Okay, all right. Any questions about how we got these numbers? All right, who is our limiting reactant then? Mg, because this is the smaller amount. So that means Mg is our limiting reactant. And so now when we need to find our volume of H2, we would have to use, the moles from the mg. So we would have PV equals nRT. So V is equal to nRT over P. So N is 0.04527 moles. I'm going to do this one just to remind you to always put in your units, 0.08206. What is the unit for the gas constant? Liter, atmosphere per mole, Kelvin or Kelvin mole. Okay, and then our temperature, 25 plus 273.15 is 298.15. 298.15 Kelvin over pressure was 1 atmosphere. Oh, that's nice. And we get 1.107 goes to 1.11 liters. Is good? Okay. So once again, there's not much to this other than just reminding yourselves how limiting and excess works. So maybe we are at 9 o'clock about there. So why don't you just do one question from each of these pages for homework? So maybe just do number 1 on page 30. Page 30, number 1. And how about page, where is it? 27, number 1. Page 27, number 1. Is good? Okay. And that's it. Done for the day. Woo! Okay.
Last week. It's fun. How was the day? Yeah.